Hello, guys, and welcome. I hope that you are well. My name is UHD King, or I play 4K, AK I play 8K, AK I play 16K, and during this video, I'm going to demonstrate Metal Gear Solid 5, the Phantom Pain PC game, running for the first time world's first 16K video resolution, 16K gameplay, 16K gaming in Metal Gear Solid 5 The Phantom Pain, available on YouTube. I'm so excited. I benched it already at low possible preset and it was successful, so I decided to go ahead and share it with you immediately over the YouTube, over my YouTube channel, uhdking.com or 15360 times 8640.com website that is dedicated to 16K UHD, 16K gameplay, 16K benchmarks. Alright, so right now it's running at the lowest possible preset. Okay, this is the beginning of the game. As you can see, the animation is rendered within the game engine, so it's not pre-rendered video. So the stats at the left top corner, the values are self explanatory and actual the real values, guys. It was verified by me. It is what it is at the left top corner. We're gonna pay our attention to the left top corner and we're going to talk about those numbers under the 16K UHD, which is 16 divided by 9 aspect ratio, 16K video resolution. This is the maximum font size for the Riva Tuner display information system under the MS Afterburner. I cannot go larger than that because it's already 132.7 megapixels rendered in real time. Alright, so as you can see, I just appeared. This is the lowest possible preset. A game is using a little bit of the blur depth of field, but the game is amazing. The character appeared in a hospital, as you can see, at the beginning of the Metal Gear Solid 5, the Phantom Pain PC game. It's beautiful looking game. I believe it was released back in 2016 when the Titan X Maxwell GPU architecture was available to us as a flagship video card. It was the Maxwell GPU architecture by Nvidia. Today I'm running the Titan RTX video card, single Titan RTX video card that is equipped with 24 GB of the video RAM. It's going to be a Turing GPU architecture by Nvidia, which is the two more generations after the Maxwell GPU architecture, after the Titan X Maxwell GPU architecture that was featuring only 12 GB of the video RAM, but the Titan RTX video card is featuring 24 GB of the video RAM, which is double of that, and performance in terms of the GPU computing performance 3x, which is triple of the power of the Titan X Maxwell GPU architecture. Keep that in mind. So let me go to options. As you can see, I just booted the game. This is the Steam version. We're not gonna go as fast as possible. This video will be around 1 hour. Go ahead and grab yourself your favorite drink. The best drink will be tea, the healthy drink with the lemon, or a coffee. Coffee is great for the vitamins as well, antioxidants. So 15,360 pixels by 8,640 pixels rendered in real time, which will be exactly 16K UHD, 16 divided by 9 aspect ratio, 16K video resolution. I'm running borderless full screen because under the full screen in 16K video resolution is a little bit flickering because the 16K video resolution is maximum video resolution for DirectX 12 API, for the OpenGL 3.6 API, for the Vulkan 1.1 API, for the CUDA API, for the OpenCL API, and for the Mantle API. So pretty much every single commercial 3D rendering real-time APIs has the capabilities of the maximum 16K video resolution 3D world rendered in real time, or 32K resolution textures, 3D textures rendered in real time, but not 3D world 3D scene. Keep that in mind. So as you can see, minimum possible preset. This is how I tried it already, but I didn't try it at the medium. So we're gonna try all kind of different presets. I'm going to go ahead and accept that. Today I'm recording this video with Nvidia Shadowplay in 8K video resolution. Nvidia driver is modified through the RAM debugger tool. So it's running a 8K resolution native with the DSR to 16K resolution, but it's rendering as 16K resolution native. Keep that in mind. Plus minus 1 FPS, just like exactly it would be doing that on a 16K resolution native screen. So it's rendering 16K resolution native and then downscaling to 8K resolution native when it's displaying the data on the cables outputting, but it's rendering as, again, this is exactly how much performance is going to take to render this game in 16K video resolution on a single Titan RTX and Intel Core i9 9900K overclock at 5.3 gigahertz. We're going to start the game. In the end of this video, I'm going to go through my PC configuration setups, and a little bit of benchmark data will be available to you. So stick around till the end of the video if you're a fan, if you're a subscriber of the UHDking.com YouTube channel. So this is going to be the beginning of the first level. And let's go ahead and have a look. As again, character in the hospital. I'm going to play like about 5 minutes, and then I'm going to switch the preset and we're going to start it over. And just because I really like it, it could be used as a benchmark, because again, it's rendering within the game engine, and pretty much the FPS will be just like I would be in the game throughout the gameplay. This 3D cutscene rendered with the game engine, pretty much showing the same FPS as it's going to be throughout the gameplay. Keep that in mind. As you can see, 9 FPS average right now. Just because it's rendering with Nvidia Shadowplay, please add 2 FPS. Without Nvidia Shadowplay, it's 2 FPS higher than that, so it's going to be 12, 13 FPS without the Nvidia Shadowplay recording. So exactly 2 FPS to the FPS counter. The MS stands for the milliseconds, so it's latency delay. So MS, that value we want to have as low as possible. The comfortable gameplay will be below 10 milliseconds. Amazing comfortable gameplay. The below 20 milliseconds still will be comfortable gameplay, but above 30 milliseconds the gameplay is not going to be playable or comfortable at all. Keep that in mind. It's going to stutter a little bit, and after 100 milliseconds it's stuttering and lagging a lot. Okay. So let me go ahead and move the camera a little bit. So this is this single procedure, and now it's going to be the animation within the game engine. So we're going to go ahead and have a look at that. And in the future, I'm going to use this as a split screen and as a benchmark while I'm going to test the future video cards, the future CPUs and PC configurations. 22,000 megabytes, almost 23,000 megabytes of our video RAM utilization, and our system RAM utilization is used almost 12,000 megabytes right now. So Titan RTX video card is featuring a little bit above 24,000 megabytes of the video RAM, which is exactly 24 gigabytes. So we still have like 2 gigabytes to go. So this is not bad. So let me go ahead and type my name. I'm going to type my name 15,360. Let me press enter first. 15,360 times 8,640.com, exactly the domain name dedicated to that. Oops, we cannot enter. Okay, we cannot enter the numbers or characters. Alright, so let me go ahead and fix that. So I'm just going to call myself UHD King. So numbers are not possible. So UHD and then King with the I guess, right? Yep, because I cannot type number 1 as my signature. Alright, so today is November 5th, 2022, but this type of technologies was available to us back in 2018, before 2019. Please keep that in mind. So November 5th, let me set it correctly. November 5th, 2022, just in case. And we're going to keep moving. Here we go. Let's go ahead and keep moving over here.
Good. Now then.
So look how beautiful
Please try to relax.
the animation in real time looks like throughout this game engine. It's just unbelievable, and this is pretty old game. It's like 6 years old, but everything is looking so great.
Not to panic. You've been in a coma for
The game has fantastic visuals. As again, guys, I'm coming in real time. I'm using the artificial intelligence noise reduction, but I'm not using the RTX voice noise reduction, which is excellent application to remove the voice noise from your voice, such as fan rotation, because the Titan RTX right now running at 100% fan rotation is dual fan Nvidia thermal compound solution, and I'm using the thermal liquid metal thermal grizzly thermal compound paste on GPU. Keep that in mind, but I'm still using the stock NVIDIA dual fan heatsink, and everything is stock. So it's going to thermal throttle a little bit even at the 100% fan rotation. As you can see, my GPU utilization 99-100% GPU utilization, exactly how we want to have it. That means that I'm utilizing all the 4608 CUDA cores without wasting any single CUDA cores, which is amazing.
It's been 1 week since you came to. Now,
The CPU utilization we want to keep below 90% all the time, 90% and above. If you're going to see that figure, that means that you got to add at least 2 more threads. Otherwise, there is a possibility that you're going to bottleneck through your CPU core, CPU thread needs, and you're not going to show the real FPS that your hardware, which is the video card, is capable. And video card is the main component in PC games throughout the 3D rendering in real time. Keep that in mind.
9 years
So
ago,
we are looking Gucci. As you can see, the frequency of the CPU is not even 5.3 gigahertz, which is 5300 megahertz. Sometimes it's lowering to 5200 megahertz. This is the native feature of the Intel 9000 series CPUs, and today I'm running Intel i9 Core i9 9900K, as again overclock at 5.3 gigahertz. But I disabled 2 physical cores, and I disabled the hyperthreading technology, which is additional 8 logical cores, because 3 logical cores under the Intel Core i9 9900K is equal 1 physical core, so it's pretty slow. So I decided to utilize only the fastest cores, the fastest physical threads as possible. So I'm only running the physical threads. Keep that in mind. Hopefully, guys, this makes sense. So we're still below 23,000 megabytes on our video RAM utilization, which is below 23 gigabytes. But to be able to run Metal Gear Solid 5, the Phantom Pain PC game, in 16K video resolution with the Nvidia GPU architectures, you need to have at least 24 gigabyte of the video RAM. Keep that in mind, guys. In the future, Nvidia will improve the texture compression through the hardware, but as again, it's not going to be even half of that. So most likely, maybe the improvements will lower it by the 1 gigabyte of the VRAM utilization, but it's still going to be 24 gigabyte in need requirements to be able to run it without any bottlenecking throughout the video RAM to store the data into the frame buffer. Hopefully, guys, this makes sense. As you can see, the game is utilizing healthy VRAM utilization. The system RAM utilization is almost 12 gigabytes. This is the normal for this game, so I can state that the game is utilizing VRAM healthy without offloading any data into the system RAM or into the storage. This is the horrible scene, by the way, but I really like this scene because it's rendered within the game engine in real time and could be used as a benchmark. And I'm going to show you a little bit of the gameplay, couple minutes as well, throughout every single preset. As again, this video is not going to be as fast as possible. This video we will go through the presets, and I will share all kind of experience that I experienced throughout this benchmark on a single Titan RTX video card. The Metal Gear Solid 5, the Phantom Pain PC game, supports, just like Ground Zero, Metal Gear Solid 5 Ground Zero supports SLI, means that 2 Titan RTXs and SLI working together will be supported in this particular game under DirectX 11 API within this game engine. Developers did a good job while developed this game. Keep that in mind. So 2 Titan RTXs will be supported, and I'm going to show you over the UHDking.com 2 Titan RTXs and SLI. It's going to be nice to see what will be FPS. Are we going to achieve the playable FPS in this game? I cannot wait to see it myself, guys. And as again, my secondary Titan RTX in a secondary system, which my server workstation, I use it for the encoding, but I'm going to use it for this benchmark over the UHDking.com, and it will be available in about a couple weeks. In 2022, I'm going to underline it, and I'm going to render this game with 2 Titan RTXs and SLI. The FPS should be doubled due to our GPU utilization is 9900 which is excellent GPU utilization, GPU usage. That means that we're utilizing every single CUDA cores without wasting CUDA cores, and that means that under the SLI is going to be excellent as well. But we're going to find out. If SLI is going to scale, it's going to be excellent if the GPU utilization on a single video card is 199%. Keep that in mind. Alright, so let me go ahead and select whatever. I don't need to select the character, but as you can see in the game, you can modify the character. The game, by the way, is amazing. Let's go ahead and use this avatar. I don't care about the avatar. I cannot believe that this game is possible in 16K video resolution and we are not overloading our VRAM, because this game is just a great visual experience in terms of the details, in terms of the graphics. This game looks amazing. As you can see, it's a little bit pixelated, so the mirrors in this game is not going to be running in 16K UHD. It's going to be probably running 720p or 1080p. I would say 720p because I saw his hair was pixelated, or maybe just a post effect, but I'm assuming that the mirror is not running at even 1080p because we saw the pixels in the mirror even under 16K video resolution. And that makes sense because the mirror is kind of the reflection, taking a lot of performance to compute, and most likely they're not using at the full resolution of the game when it comes to the mirrors and reflections for this particular game. As again, this scene is not easy scene, but it's great. It could be used as a benchmark, as again, because the FPS under the test that I did today earlier was just the same throughout the gameplay, just like it is throughout this benchmark. As you can see, it's a little bit pixelated. That means that most likely this is 720p reflection in the mirror. That's why we can see those pixels under the 16K video resolution. So it's not using the original resolution for the mirrors and reflections, which is fine. We're not going to be focused on the reflections in this game anyway. So 720p for the reflections, still great for the reflections or the shadows in PC games, if it's done properly. And in this game it's done properly. Everything is done nice with a great style. I really like the visuals in this game. So game developers did a good job for 2016 PC game. Keep that in mind. This game was amazing in 2016 when Titan X Maxwell GPU architecture was the flagship and GTX 980 Ti video cards. But GTX 980 Ti video card didn't feature 12 GB of video RAM, just like Titan X Maxwell GPU architecture did. But today, Titan RTX featuring double of that video RAM, which is 24 GB of the video RAM. Alright, so the latency delay in terms of the MS milliseconds is way above 70 milliseconds. So that means that the gameplay is stuttering, it's not playable. Everything which is above 30 milliseconds is stuttering and lagging. Everything above 100 milliseconds is completely not playable, only probably benchmarkable. Keep that in mind. But as again, the purpose of this video as the first vertex, the first coordinate in our 16K UHD, 16K benchmarking, 16K gameplay over the UHDking.com YouTube channel. And this is the first video card that allow us to run the Metal Gear Solid 5, the Phantom Pain PC game in 16K UHD, which is 16 divided by 9 aspect ratio, guys. 132.7 megapixels rendered in real time, which is 110 gigapixels rendered in real time, guys, with a beautiful way above 10 FPS, which is amazing. And as again, this type of technologies was available back in 2018, but today is November 5th, 2022. The newer video cards will show even better performance, especially when we're talking flagships, but 24 GB of video RAM is required for 16K video resolution. 16K video resolution pretty much will be 4 8K resolution displays. So now you understand why I play 16K, because I'm demonstrating a lot of gameplays under the 16K video resolution, and I was the first YouTuber that showed you guys 16K video resolution back in 2015. It was Counter-Strike Source PC game, but it was over different YouTube channel Over this YouTube channel, I was also the first YouTuber that introduced you to 16K video resolution, but back in 2016. It was with Half-Life 2 PC game. Let me know in comments below if you're watching my channel since then. It was for Titan X Maxwell GPU architecture and Crossfire during that time. Alright, so FPS is way above 10 FPS but below 20 FPS average, sticking around on average 14 FPS average, like 14-15 FPS average, but just because it's recording with Nvidia Shadowplay, you can add 2 FPS easy to the FPS counter, so it's around 16-17 FPS average on a single Titan RTX video card. That means that 2 Titan RTXs and SLI will show at least like 25 FPS. It's probably not going to show exactly double FPS even if it shoot under 99-100% GPU utilization, because 2 Titan RTXs and SLI will thermal much heavier than it is right now, because the first video card closest to the CPU will be very hot, keep that in mind, and it's going to thermal throttle heavier than it is right now. Wow, that's a gameplay right here. Let me change the reverse camera. I gotta reverse the camera. I'm not sure why they're doing that. As you can see, mouse cursor doesn't work correctly, doesn't recognize the user interface correctly, so I gotta use the keyboard under the 16K video resolution. But in the game it's nice, but throughout the user interface, such as the menu, it's not registering correctly. So graphics, let me real quick go ahead and I don't think it's going to be graphics. I think it's going to be under the camera settings. Yeah, under the camera settings. So y-axis we should put normal. Here we go. So the mouse is not going to be, movement is not going to be under the reverse. Here we go. Let me go ahead and demonstrate a little bit of the gameplay for you, but the game is running nice, guys. It's running great. Actually, it's under the playable status, to be honest with you. But as again, it's not like playable, but I still can play it like that, especially if I know the game. Keep that in mind. But as again, the purpose of this video is not the playable status. The purpose of this video is to benchmark under the 16K video resolution as the first coordinates in our 16K video resolution benchmarking in Metal Gear Solid 5, the Phantom Pain PC game that we're going to use in the future, because this is very benchable game with a great scenes rendered as a benchmarks could be used. As you can see, look at those details. Details are amazing, guys. The game running great, guys. I really like it. Everything is solid. Let me use the zoom tool, Microsoft zoom tool, and zoom in into the details a little bit. So this is 200% zoom tool under the Microsoft magnifier zoom tool. This is going to be 300%, 400%. Let me just zoom in into some details just to show you that you're gonna miss under the 4K resolution even running. Look at those little scratches right there on the ceiling. So that means that if you're gonna run this is 500% zoom. I'm zooming into 16K resolution with a 500%, so this is more than 32K resolution. But those, look at those scratches and cracks right there on the ceiling. It's looking amazing. Most likely under the 4K resolution you're still going to render them, but they're going to be so blurry because you're going to lose a lot of details of the texture. A lot of those pixels will be lost because you're going to render every single texture details only when you're going to look like that, like into the wall. But if you're going to look at like at 3D objects at the distance, like let's say that car probably 1080p texture, but if you're gonna render it in 4K resolution as native, that car right there will be probably 256 pixels rendered as 256 pixels. That means that you're not going to render the full texture, which is 1080p, if that car is 1080p. But it could be even 2K resolution texture, keep that in mind. That means that you're going to lose a lot of details, and even under 4K resolution, you're not going to render the full texture details of the 3D model. Hopefully guys this makes sense. So I just real quick explain to you why 8K resolution and 16K resolution is important when compared to 4K resolution, because you're gonna receive that rich experience where every single pixel on that texture will be rendered, and 4K resolution is not capable to render every single pixel, because when the object at the distance, you're losing that details in terms of the pixels, because your screen is not capable to render that amount of the full texture of that pixels on that 3D object. Hopefully guys this makes sense. So we're about to wrap it up. Right now is going to be another great scene with a lot of particles. I just want to check it out, and right over here, and then we're gonna go ahead and switch it, as again this part could be also used as a benchmark. So average 14 FPS pretty much while it was recording with Nvidia Shadowplay in 8K UHD. So please watch in your YouTube player 8K UHD for the full experience, guys. Switch in your YouTube player to 4320p or 8K UHD for the maximum visuals, for the best possible experience. Look at this. Right now there is a dynamic particles and volumetric particles inside. Probably the sprites, a lot of sprites going on, but as again, a lot of post-processing rendered in real time, so it's nice to see. But the FPS is kind of average. The developers did a good job, the game developers of the Metal Gear Solid 5, the Phantom Pain PC game did a good job, as you can see, in terms of the utilization, in terms of the video RAM utilization also. Look like they predicted that the game could be possible, runnable in 16K video resolution if you're going to have 24 gigabyte of video RAM, and this is just unbelievable, guys. We didn't overload our VRAM. I thought that Metal Gear Solid 5, the Phantom Pain PC game, would overload our video RAM, but it didn't. But as again, under the lowest possible preset, but even the lowest possible preset under the 16K video resolution looking amazing. Imagine to run this game with RTX 4090 video card. RTX 4090 video card shows at least 3 times more performance versus the Titan RTX video card. So your FPS should be 3 times at least to the left top corner. So on the RTX 4090 video card, which is the ADA GPU architecture by Nvidia, your FPS should be around like 36, even around 40 FPS average, and this is going to be amazing, guys. I'm going to test it over the UHDking.com, the Metal Gear Solid 5 Phantom Pain PC game in 16K video resolution, 8K video resolution, 10K video resolution, 12K resolution, with all kind of different hardware, with all kind of different video cards, with all kind of different PC configurations. So go ahead and check it out, that website, that YouTube channel, which is the best. For 16K UHD, you want to check out, as again, 15,360 times 8,640.com. Website is going to be dedicated to 16K gaming, 16K gameplay, 16K benchmarking. Keep that in mind. It's going to be a great videos for people, for the gamers that looking to the maximum visuals in PC gaming. Alright, so still below 24,000 megabytes of the video RAM utilization. This is unbelievable. I'm pretty sure if we're going to increase our visual settings, the video RAM utilization will increase as well. But if it's not going to increase, as again, I didn't test it under the medium or high presets, if it's not going to increase our video RAM utilization, that means there is something going on with the game engine, and maybe it's allocating the video RAM properly and the kind of throttling the video RAM utilization frame buffer. Maybe then, but we're going to find out. Video RAM utilization should increase, but if it's not going to increase, then there is a possibility that we're throttling, and the game engine is checking and make sure that we're not going to overload our VRAM, and maybe the game is going to crash if we're gonna overload our VRAM in this particular game. But maybe not. We're going to find out when I'm going to switch to a medium preset in a few seconds. I'm about to switch it right now. So pretty much I showed you the introduction videos rendered within the game engine. I showed you guys the gameplay footage as well. So everything is covered. Let's go ahead and switch the preset and we're gonna restart the mission. Let me go ahead and do that. So options and graphics settings. Here we go. Now I'm gonna put everything to a medium. It's nice to see to a medium, and then it's going to be the maximum preset. So what I'm gonna do, depth of field, I'm gonna stay away from depth of field, but model details I'm going to increase to medium. Texture details I'm going to increase to medium, but as again, if you're playing 8K video resolution or above, you want to keep your textures to the maximum possible visual settings throughout the game menu. Keep that in mind. Shadows, we're going to keep medium, just everything at medium just to make sure. Alright, lighting, we cannot have low or high, but I still can have extra high. Let's keep it at high. Post processing, I can have low, high, or off, or extra high. Let me keep it low. Kinda, we're gonna consider this as a medium. FX, let me keep under the high because the extra high is the better option. Let's keep the effects at high. Ambient occlusion, I'm gonna keep it off because ambient occlusion taxing a lot of about 15% of the Turing GPU architecture almost in any games that I tested under the 8K video resolution or above. So we want to keep it off. Ambient occlusion pretty much is kind of shadows around every single edge on 3D model, and when those polygons connected with the edges, it's creating like that shadow effects to it, like darkish and lightish spots, and it's creating like fake lighting. It's kind of like inner shadows in Photoshop on the layers. Keep that in mind. Volumetric clouds, let's keep it off for the medium. I'm going to go ahead and accept that. Hopefully the game is not going to crash, as again I didn't test it anything above low presets yet. Alright, and what I'm gonna do, I'm going to go ahead and restart the game. So we're gonna go ahead and restart the game. Everything is slow right now, guys. Let me accept that. And somehow my keyboard is not responding. Here we go. Now it's responding, but the game is still refreshing, so the game is not frozen. Alright, so I'm going to go ahead and restart the game right now. So under the medium, the VRAM utilization almost the same. So hopefully the game is not throttling in terms of the video RAM utilization. Maybe it's done artificially, so VRAM utilization cannot go above 24,000 megabytes. Maybe the game developers envision that type of scenarios just to make sure that you're not going to overload your video RAM and it has the capabilities to throttling your video RAM usage. Possibility, but could be not. We're going to find out. But as you can see, FPS is lowered, so this is a great sign. So at least this is utilizing the medium preset now because we have double less of the FPS. So from 14 FPS we went to 7 FPS, but the video RAM utilization is still pretty much below 23,000 megabytes. I'm not sure why. We're going to find out under the maximum visual presets. If the video RAM utilization is not going to increase, then this is a clear sign that the game engine is throttling the video RAM usage, and it's make sure that you're not going to overload your video RAM. In this case, most likely it's not showing the maximum FPS that the GPU technology is capable to render. Alright, let me go ahead and move the head. Here we go. That mouse under the reverse is the y-axis is horrible. I'm not sure why developers doing that. Should be normal. But yes, indeed, we lowered in terms of the FPS. So the settings is applied in real time. You don't need to reboot this game while you're switching the settings under the same resolution. So we are Gucci in terms of that. And you can see the reflection of that at the left top corner. Alright, so okay, alright. Yeah, the increase in terms of the video RAM utilization now is above 23,000 megabytes, and system RAM utilization is almost 12,000 megabytes. But system RAM utilization is the same. That's a clear sign that we are not offloading any data from a VRAM into the system RAM. Maybe it's uploading some data into the storage. There is a possibility, but storage such as SSD is pretty slow, and I'm only using the SSDs right now in this system. The game is installed on SSD, keep that in mind. When compared to video RAM, storage, offloading data from the video RAM into the storage will create a lot of lag, a lot of stuttering, and low FPS. Even offloading data from a video RAM into the system RAM. System RAM is about, guys, check it out. My video RAM right now is 769 gigabytes per second bandwidth, and system RAM bandwidth is only 50 gigabytes per second. So pretty much I'm at least 12x, 12 times faster in terms of my video RAM bandwidth versus the, let me go ahead and accept that, versus the system RAM bandwidth. So it makes sense, right? Let me just accept and write anything in this time. Come on, just H, whatever. Create the character, please. Okay, here we go. I'm gonna click OK. Here we go. We had that checkpoint. Look how everything is looking great. At the medium preset, this game is amazing. Cannot wait to see this game under the 16K video resolution with the maximum preset. It's probably going to look just amazing, guys. Look at that, every single detail right now under the medium. I showed you zoom in with the low possible presets, and even the textures didn't display all amount of the pixel data because the low preset is a little bit blurring the textures, and it's not loading the every single pixel of the texture into the rendering pipeline of our game engine. Keep that in mind. I cannot wait to see 500% zoom under the maximum visuals in this game under the 16K video resolution, just to compare the textures. It's probably going to look great, guys. But we're going to compare throughout this gameplay, throughout this 16K benchmark. Keep that in mind. Almost 24,000 megabytes of our video RAM utilization, so it's not compensating the video RAM utilization. It's using the video RAM utilization without controlling it, just using the DirectX 11 API the way it's using by Microsoft. The game engine is utilizing it as well, so it's not controlling or not manipulating the video RAM. Look like the medium preset versus the low preset, just a little bit of the improvements, but not that much. So that's why the video RAM utilization is not that crazy yet, but I'm pretty sure after I'm going to switch to the maximum visuals without the anti-aliasing, because anti-aliasing most likely is not going to be possible. Our VRAM utilization going to be overloaded, or game could be crashing on us, or we're going to use a lot of system RAM utilization. You're going to use that, see that system RAM utilization probably going to go above 12,000 megabytes, and it's going to be a clear sign that we are offloading some data from a video RAM into the system RAM. But it's going to be nice to see this game with the 48 gigabytes of the video RAM video card in the future. And as again, this is the first vertex in our 16K resolution video benchmark in PC games under the Metal Gear Solid 5, the Phantom Pain PC game, with the first video card that is capable to run the first GPU architecture by Nvidia that is capable to run this game under the 16K video resolution. And technology will improve, and we're gonna see exactly how much video RAM is required to run this game with a healthy video RAM utilization. But I think that 24 gigabyte will be more than enough at low preset and medium preset. I think that VRAM utilization in the left top corner is the correct data value right there, guys. And as again, every single value at the left top corner was verified and correct, so you can trust it. Keep that in mind, including the voltages on the CPU, GPU is correct. Titan RTX is thermal throttling because the Titan RTX Turing GPU architecture video card will be thermal throttling if you're going to run dual fan design by the Nvidia Founders Edition, as I'm running right now. Even if I'm running the liquid metal thermal compound paste by Thermal Grizzly, it's still thermal throttling after it's reaching 60 Celsius. Keep that in mind. After 60 Celsius, Titan RTX, I think it's 62 Celsius, Titan RTX showing the thermal throttling signs, means that it's lowering its frequency on the GPU, and it's lowering its temperature automatically and voltage as well. So it's consuming less power, creating less heat through an artificial thermal throttling process by the Nvidia driver. Hopefully, guys, this makes sense. This is the scenario for the Turing GPU architecture. for the Titan RTX video card or the RTX 2080 Ti video card that is utilizing almost the same technology and almost the same GPU as GU102 in our Titan RTX video card, but in RTX 2080 Ti video card, that GPU has 256 CUDA core less than Titan RTX, and it could increase even 1 FPS, especially when those 256 CUDA cores utilized with the two Titan RTXs in SLI, and it's going to give you an advantage 512 CUDA cores versus the two RTX 2080 Ti video cards, and it's going to be a solid boost, guys, in terms of the FPS. But as again, RTX 2080 Ti video card is not possible under the 16K video resolution due to VRAM usage. We're going to overload our VRAM because the RTX 2080 Ti video card with the Turing GPU architecture is only featuring 11 GB of the VRAM, while VRAM right now is almost utilizing 24,000 megabytes of the video RAM, as you can see at the left top corner. As again, your eye should be focused at the left top corner, guys. At the same time, keep watching the beautiful 3D animation, but most likely if you Metal Gear Solid 5 fan, most likely you know this scene. As again, as you can see, this reflection is like most likely 720p because I can see the pixels on the hair. So reflections done probably 720p or maybe 1080p as a maximum because you can see the pixels, but that's fine. As again, we're not going to see those reflections a lot, and most likely those reflections will be applied on small 3D objects, which will be fine even in 720p resolution. As again, this game is not utilizing RTX technology at all, so reflection done through the manipulation of the reflection and refraction. Keep that in mind. So it's not utilizing the ray tracing capabilities of the RTX technology, even if the Titan RTX is the first generation of the RTX video cards and it's supporting the ray tracing capabilities by the Nvidia. But the Metal Gear Solid 5, the Phantom Pain PC game, is not utilizing the classic, this is the original vanilla game, is not utilizing the RTX technology or ray tracing technology. There is refraction and reflection capabilities and great lighting capabilities within the game engine, but it's done through the manipulation. It's a fakish, it's not the RTX technology by the Nvidia. So RTX cores are not utilized, keep that in mind. Also the tensor cores, which is the artificial intelligence cores, are not utilized in this particular game as well. So artificial intelligence through the hardware capabilities is not utilized as well. It's nice to see when game developers will include the utilization of the artificial intelligence hardware capabilities in the future, because they can improve the game experience by a lot to a gamer. Keep that in mind. So if you're a game developer, you want to pay attention to the artificial intelligence hardware capabilities, tensor cores on the Nvidia GPUs, and utilize it in the future. Also, AMD GPUs also have the artificial intelligence cores as well. Any type of GPUs released in 2022 capable and featuring the artificial intelligence hardware acceleration capabilities, and it's nice to utilize that, especially when you're using the NPCs and artificial intelligence in games, just to bring the artificial intelligence when the computer AI thinking on another level and it's more complex, and it's creating the richer gaming experience. So if you're a game developer watching this, hopefully you're going to improve through your game development and you're going to utilize the artificial intelligence hardware capabilities. Alright, so 12 FPS, not bad FPS. So two Titan RTX is most likely going to show 20 FPS over here. And as again, this game is supported SLI, and I was running 4 Titan X Maxwell GPU architecture back in 2016 throughout my benchmark in 8K video resolution over the UHDking.com. Go ahead and check it out. Just watch the playlist of the 4 Titan X Maxwell GPU architecture. It's going to be 7K video resolution in this game and 8K video resolution in this game with 12 GB of video RAM, which was more than enough under the 7K and 8K video resolution. Alright, as again, the 3D scene rendered within the game engine is amazing. It's almost like a Pixar movie, and this is done in real time, guys. And this is in the game technologies in 2016 that was available to us back in 2014 throughout the game engines. So you can imagine in 2022 if the game developers will use the full hardware capabilities and 3D accelerations by the hardware that is available today, the visual should be on another level. But look like the console is slow down the progress because the game developers trying to make the cross-platform games on the consoles and PCs. That's why the visuals is not at the level that today's hardware is capable to push, because they're trying to make compatible with the consoles, and consoles has the very slow hardware capabilities on the consoles when it comes to the PC hardware in 2022. Keep that in mind. So pretty much medium preset is tested. I'm about to switch to maximum visual preset, but I'm going to demonstrate a little bit of the gameplay, but we see the difference now. Almost the same FPS. That's why the video RAM utilization was also the same, because the decrease in terms of the FPS was like couple FPS. It wasn't that big deal. But visuals improved by a little bit. I can see it. It's improved by a little bit, much clearer, much detailed in terms of the even texture rendering, shaders rendering in real time, with better feature details, more pixels rendered in real time, because when the texture is set to low, the amount of the pixels is not rendered with the full texture capabilities of those pixels. Keep that in mind. It's kind of blurred out. It's mixing two pixels into one pixel, and it's utilizing less VRAM. The reason why it's done, so it's utilizing less VRAM for the gamer on the user hardware. Keep that in mind. The game looks amazing, and this is medium preset. Cannot wait to see this game on the maximum visuals. It's probably going to look amazing, but I think the VRAM utilization at the maximum visuals, even without the anti-aliasing, will be like way about 24,000 megabytes. And I'm pretty sure our system RAM utilization most likely will be way below, way above, I would say, 12,000 megabytes. Right now, it's still the system RAM utilization below 12,000 megabytes. I can clearly state that most likely our VRAM utilization is a healthy VRAM utilization, and we are not offloading any data from a VRAM into the system RAM. Or maybe we're offloading just a little bit of data from the video RAM into the system RAM just to compensate, because most likely the DirectX 11 API and the game engine is not going to wait when we're going to overload our VRAM and the game is going to crash. It's going to start predicting before it's going to happen, and I think that Turing GPU architecture with Nvidia driver is predicting VRAM overload starting after 20,000 megabytes or 20 gigabytes, because 4 gigabytes left, and if game is utilizing above 20 gigabytes of the video RAM, I think the driver is paying attention and under the focus to make sure that already start offloading some data into the system RAM, because there is a possibility at some complex scene we can overload that 24,000 megabytes of the VRAM. So it's just a compensating and just using the insurance of that and start offloading some data after the 20 gigabytes of the video RAM in a lot of games. But as again, it's based to the game and game engine. Keep that in mind. Look like this game is not offloading any video RAM data into the system RAM yet, because we didn't increase our system RAM utilization after I switched the preset. We're gonna find out about our VRAM utilization when I'm gonna switch to the maximum visuals. Alright, so everything looking great. So we tested that thing. We saw the in-game 3D rendering capabilities, 3D scene, and the gameplay footage. Let's go ahead and switch now. I'm going to switch, guys. As again, I'm coming real time. This is going to be one scene, one video recording without any editing. Keep that in mind. I'm going to edit this video. So I'm going to keep now everything to the maximum possible preset except the motion blur, because we're gonna blur out anyways throughout the video encoding process on YouTube. So we're gonna blur out some pixels anyway. So when you're recording your footage, you don't want to use the motion blur, because you're gonna use kind of artificial motion blur through the video encoding. Hopefully, guys, this makes sense. So maximum possible visuals and everything, as you can see, except the motion blur is off, without the ambient occlusion, and then I'm going to include the ambient occlusion. I'm pretty sure it's going to text just a little bit just to see the difference. So you're going to start without the ambient occlusion, and then I'm going to enable the ambient occlusion. So maximum possible visuals Okay, right now the texture is set at extra high. Most likely we're going to overload our VRAM, but we're about to find out. If we're going to overload our VRAM, our FPS is going to crash and milliseconds latency delay will go above 300 milliseconds. When your latency delay above 150 milliseconds, that's a clear sign that you're overloading your VRAM or your GPU is not capable to render in real time the data. But the FPS will be low when this scenario will happen, especially when FPS will go above 150 milliseconds. Your FPS most likely will be like 3-4 FPS. Alright, so let's go ahead and switch it. So maximum visual preset, I'm going to go ahead and restart the mission. And let's go ahead and have a look one more time. This is going to be the last preset without the ambient occlusion, and then throughout the gameplay I'm going to try to enable ambient occlusion, and we're going to see the difference in terms of the FPS, frames per second. Okay, so right now the shaders will be compiled properly with the maximum visuals, maximum capabilities in this game. So every single pixel will be rendered. And look at this, the VRAM is still below 24,000 megabytes. So I can clearly state that this game can control the VRAM utilization pretty well, this game engine and the whole game. So game developers did a good job, and as you can see our system RAM utilization increased to almost 13,000 megabytes. So this is a clear sign that we already offloaded at least 1 gigabyte of the data from a video RAM into the system RAM, and video RAM is still the same, so that extra 1 gigabyte was offloaded in real time from video RAM into the system RAM just to make sure that we're not going to crash the game. FPS is lowered as well by a few FPS, not by a lot, but you can see it in terms of the visuals. Right now everything is much clearer, everything is much detailed, much smoother looking, even the 3D models looking more like without those hardish edges, more like a tessellated into the 3D meshes, even when it's not. But when you switch into 16K video resolution, everything looks much better. The reason why, I believe, because the amount of pixels actually rendered, and it's giving you that feeling, that fakish feeling, like you just increase in terms of the polygons in your PC game, but you're not. You just increase in terms of the pixels, not the polygons, but it's giving you that type of effect. And I can see that fakish effect as a 3D artist, and it's kind of hard to fake for me anything something like that because I'm a professional 3D artist, 3D animator, but it's giving you that type of fake feeling to it, and game looks on another level, guys, even on the 8K resolution native screen rendered and outputted, but it's, as again, it's rendering 16K video resolution. This is exactly how much it will take to render 16K video resolution, as you can see right now, that much performance. And then the signal is outputted and downscale, but it's rendering without the upscale. Upscale is bad, guys. You want to render native resolution and you want to downscale. Downscale is good, upscale is bad. You're losing the details when you upscaling, and but downscaling is good because you making richer details at the lower resolution. Okay, we decreased in terms of the FPS by about 2 FPS, I would say, when we went from medium to high. But as again, I'm not using any anti-aliasing. I'm pretty sure if I'm going to enable the anti-aliasing in this game, everything will crash because we are immediately going to overload our VRAM, or our system RAM utilization probably going to reach like way above 24,000 megabytes, just a system RAM utilization. We're going to offload a lot of data. It depends to the game engine, but I will try in the end of this video. Hopefully the game is not going to crash on us. Alright, come on, dude, just move on. Okay, so it's moving. The level of details is just unbelievable. Let me use the zoom tool just to show you. I'm going to use the magnifier windows to look at this. Every single detail is rendered, every single pixel is rendered, and this is 500%, this is 400%, this is 300%, this is 200%, and this is 100%. Under the magnifier, you saw those level of details. Alright, so it's asking our name. Let's go ahead and go through that real quick. Okay, I'm going to use the H. I'm fine with that. Apply to that, and I'm fine with any type of characters. Again, the Purpose of this video is 16K video resolution benchmarking. It's clear. 16K gameplay, 16K test, 16K video resolution testing capabilities is pretty much explained throughout this game fully on Titan RTX video card Turing GPU architecture from A to Z, guys, in this particular game. So hopefully you loved my materials, my content. Don't forget to smash that like button. A lot of time, money, energy. Subscribe, share it with your friends. This is not the copycat. This is unique, and UHD King or me is the first YouTuber that show you 16K video resolution gameplay on YouTube back in 2015, but over this YouTube channel back in 2016 with Half-Life 2 video. But my first video ever was with 16K video resolution on a 4 Radeon R9 290s, and it was Counter-Strike Source 16K video resolution back in 2015, guys, because the video RAM utilization was low under that type of game. It was possible to run that type of game with the R9 290s because AMD is utilizing, or ATI during that time, is utilizing less video RAM than Nvidia technology, GPU technologies. Why? Because it's using a little bit better texture compression methods through the hardware. Keep that in mind, that Nvidia. At least this was the case with R9 290s back in 2014 when I have 4 of them in Crossfire X. But of course, it wouldn't be possible to run this game on the R9 290s. I still have them, guys, 4 of them. They only featuring 4 GB of the video RAM. But the old school games such as Counter-Strike Source under the 16K resolution, it's no problem. I was also be able to run 10K resolution in Crysis with 4 GB of the video RAM on 4. No, it wasn't 10K, it was 7K. It was just below the 8K. 8K resolution was crashing on 4 R9 290s in Crossfire, but 7K and 6K. 6K was runnable, 7K was runnable at low FPS. Most likely was overloading our VRAM. That's how I remember it. But I didn't introduce any gameplay videos throughout that time yet, guys. But I tried. 6K resolution was runnable in Crysis 3 with 4 R9 290s AMD video cards in Crossfire from 2014. I believe the GPUs was Fuji XTs called. Fury X, sorry. No, it wasn't Fury X, it was R9 290. Fury X actually, I believe, the next GPU technology by the AMD. Yeah, it was the next after that. Look at that, the visuals is just unbelievable. The level of details, I can see the scratches on the wall right there. And most likely you're not gonna see it with a 1080p resolution. Everything will be blurred out. That amount of pixels of the texture on the wall will be blurred out. But I can see the scratches on the wall right there. Alright, so VRAM utilization is almost 24,000 megabytes and system RAM utilization is almost 13,000 megabytes. So we are offloaded 1 gigabyte of the data from the video RAM into the system RAM, which is kind of low actually. Something is going on here. Guys, I'm going to record 8K video resolution in Metal Gear Solid 5, the Phantom Pain PC game, and it's nice to compare the FPS, but usually 4K resolution difference and 8K resolution will be 3.5 times in terms of the FPS, and same type of the FPS when we compared the 8K resolution to 16K video resolution in 99% of the games. It's going to be like 3.5 times 16K video resolution using less FPS versus the 8K video resolution. Keep that in mind. It's not 4x, it should be 4x based on mathematics, but just because Nvidia using some compressions, the video RAM utilization and FPS is a little bit higher than it's supposed to. Okay, alright. I'm pretty sure if I'm going to enable the ambient occlusion, our FPS gonna go like to 5 FPS, but we're going to find out. So as you can see, even at the maximum visual, the reflection and refraction is probably going to be at 720p because everything is pixelated in that mirror. As you can see, I think it's 720p, which is more than enough, to be honest with you, because as again, if you're going to enable that reflection on a small 3D object, it's just going to be perfect. Most likely even 720p on a small 3D object in 4K resolution, you're not going to utilize the full texture of that reflection texture, reflection material map. Use this avatar. Yes, let's go ahead and use that. I don't care about the avatar. Guys, I never finished this game. I know this game is amazing, but I never finished this game. I never progressed through this hospital. And I know this game is amazing, but just because I'm testing a lot of hardware and spending a lot of time, guys, for your benchmarks, don't forget, as again, to support me with your like and positive comments and comments down below, and share it with your friends, share it on some other websites, guys. Support me. I need your support so more people can see it, and I will buy more hardware, and I'm going to spend more time for the 8K video resolution benchmarks and above. And as you can see, my information, my data, my benchmarks are the best on the YouTube because they're not copycats, and I'm very precise when I'm doing the benchmarks. Make sure that everything is correct and verified before doing them. And as again, my desktop resolution is set to 16K video resolution at 100% scale, and this is very crucial in a lot of games. You want to set at 100% scale your desktop to 16K video resolution just in case, so we're rendering without any issues 16K resolution native, no matter what is the scenario or what kind of game engine we're using. Beautiful, beautiful FPS. Actually, with two Titan RTXs, maximum visuals most likely will be even playable status. Not comfortable, but probably playable. Way above benchmarking status with two Titan RTXs and SLI. Because the FPS should be almost double. So we are going to have at least like 14 FPS, maybe even sometimes 16 FPS. As you can see, the lines of the edges of 3D model needs to have some anti-aliasing, so most likely they're using 720p in terms of the reflections. When compared to the 3D world without the reflections, everything is so nice and so like anti-aliasing, and I'm not using any anti-aliasing right now. This game is designed for the consoles, that's why it's using a low type of video RAM, because consoles doesn't feature a lot of video RAM, and yeah, it's pretty well optimized as well throughout the levels, so FPS is kind of average and it's kind of keeping the same no matter where you at. So this is a proper game development right here. So the game developers in Metal Gear Solid 5, the Phantom Pain PC game, and Ground Zero PC game did a fantastic job, guys. Both of those games utilizing the SLI. Even 4 Titan X Maxwell GPU architecture was utilized in Metal Gear Solid 5, the Phantom Pain, and Metal Gear Solid 5, the Ground Zero. So SLI will be utilized. I'm also going to show you the Metal Gear Solid 5, the Ground Zero PC game as well. It's a previous episode of the Metal Gear Solid 5 PC game. We're gonna benchmark it as well in 8K resolution, 4K resolution, 5K resolution, 7K resolution, 10K resolution, 12K resolution, and 16K video resolution. I will try to underline all type of resolutions in every single game that I'm benchmarking over the UHD King. So you're gonna see the variety of the benchmark, the variety of the resolution, the variety of the presets. So you're going to build the computers better after watching and receiving this data and analyzing this data, guys. And I advise you to build the computers from the used parts, but be smart, and you're going to save a lot of money, and you're going to experience a great experience as a PC gamer if you're going to do that. This is how I started. This is how I learned. And I would be building myself a computers from the used parts. This is the best probably ways to build a computer, but just because I have you guys, I have my YouTube channel, it went popular, so I decided to go ahead and do it. So I'm investing a lot of money into you guys. But as again, I'm looking for your support, so please support me so I will buy more hardware because it's on my pocket, and I will test more hardware in the future. All what I'm asking you guys to smash that like button, subscribe, positive comments, watch my ads, watch my sponsors, and I'm gonna receive those paintings, invest back into you. I'm also giving some games giveaways all the time, so investing back those monies back into my subscribers, into my watchers. So support me, guys. Beautiful looking game, especially at the maximum visuals. I really like the style. It doesn't look high polygons models here. Doesn't look something like high tech in terms of the 3D rendering, but the style is great of those kind of low polygons models, and the textures, everything in this game is looking great, guys. In kind of Metal Gear Solid 5 style, Metal Gear Solid PC game style from the consoles when it was first time introduced on the PlayStation back in, like, I believe 1997, if I'm not mistaken, 1998 on Sony PlayStation, the first console that was utilizing the CD-ROMs back in those days. After the cartridges was used on any single consoles, like 8-bit, 16-bit was utilizing the cartridges, and the Sony PlayStation and Panasonic 3D was utilizing the first consoles as utilizing the CD-ROMs. Alright, so 7 FPS, maximum visuals, look at this. This is just unbelievable. Unbelievable, guys. And it's running actually without the stuttering. It's low FPS, but it's running without the stuttering. Cannot wait to see two Titan RTXs and SLI. And as again, stuttering because the FPS is way below 150 FPS. When FPS is reaching above 150, 160 FPS, I mean milliseconds, not the FPS. When the milliseconds reaching above 150 milliseconds latency delay, this is when stuttering starts, especially when your milliseconds will be above 300 milliseconds. This is where the heavy stuttering will be. Kind of lag, kind of stuttering, you're gonna feel it. But right now I don't feel it in this game. I feel like the FPS is low, but there is no stuttering at all. This is a great thing. That means that Turing GPU architecture is fully capable to render this game. That means the newer GPU architecture will have no problems at all, because they're gonna feature the lower level second cache on the GPU. Turing GPU architecture is only featuring 6 megabytes of level second cache on the GPU, GU102, and Maxwell GPU architecture and Pascal GPU architecture was only featuring 2 megabytes of level second cache on the GPUs, and Ada GPU architecture featuring way above 6 megabytes of the level second cache on the GPU architecture, while the Ampere GPU architecture, which is the next GPU architecture after the Turing GPU architecture, which is the RTX 3000 series video cards, was also featuring 6 megabytes of the level second cache on the GPU. But level second cache on the GPU actually can improve the rendering performance in real time, guys. The GPU rendering power for the GPU architecture, and I believe the Ada GPU architecture with the RTX 4090 video card will show at least 3x in terms of the performance here. So hopefully the FPS under maximum visuals in 16K video resolution in Metal Gear Solid 5, the Phantom Pain PC game with RTX 4090 video card will demonstrate here at least 21 FPS, at least 3 times 21, 27 FPS. This is what I'm hoping for, but there is a possibility could be also reaching the 30 FPS, well above 3 times in terms of the performance boost, because the RTX 4090 video card, when the GPU is fully utilized at 9900%, as the case in our case over here at the left top corner, most likely going to show at least 3x in terms of the FPS boost, but usually it's like 3x, 3.2 times. So if it's going to be 3.2 times when the FPS is 8 FPS average, that means that it's going to be like 27 FPS average, almost playable status under the 16K video resolution. This is impressive for the game, for such a great looking game. Keep that in mind. and not very old game, by the way, as well. Alright guys, so here what it is. I'm about to enable the ambient occlusion just to show you what will be the taxing on the GPU performance and FPS when I'm going to enable the ambient occlusion, but the game looks amazing, guys. As again, please watch this video in 8K video resolution on full screen. Just switching your YouTube player to 8K UHD or to 4320p for the best possible maximum visual experience. But 132.7 megapixels, which is 1/10 of the gigapixels rendered in real time. This is unheard of, guys. This is like a NASA technology, because NASA is using 132 megapixels as their maximum megapixels for all kind of monitoring. So I'm right now not even monitoring, I'm rendering a game in real time. And as again, this type of technology was available back in 2018. You could play it with single Titan RTX, same FPS back in 2018. But as again, two Titan RTX is going to double the FPS, and it was possible back in 2018, guys. Unfortunately, RTX 2080 Ti video card is not capable to run it due to video RAM overload, and RTX 2080 Ti video card, even the same Turing GPU architecture, but only featuring 11 GB of video RAM, which is going to be overloaded because we are using double of that video RAM right now. Beautiful. So let me go ahead. So 6-7 FPS while it's recording with Nvidia Shadow Player. That means without the recording it's going to be 2 FPS higher than that. Let me real quick go ahead and enable the ambient occlusion. Let me skip the scene, and I'm just going to enable the ambient occlusion, and we're gonna go ahead and wrap it up. I'm gonna introduce you to my PC configuration, but let's go ahead and enable that. I'm just curious how it's going to tax the Turing GPU architecture with the ambient occlusion in this particular game. As again, usually it's like 10-15% on Turing GPU architecture. It's still taxing the Turing GPU architecture, so it's not fast enough. And I believe it's due to the level second cache in the GPU, because it's kind of most likely it's pre-caching, and level second cache in the GPU will make the pre-caching way faster in terms of the latencies, and in terms of it can pre-cache in real time the amount of data. So at the same time, way more data with way above on either GPU architecture that featuring way above 6 megabytes of the level second cache, as Turing or Ampere GPU architecture is capable to feature as maximum level second cache on the GPU. So ambient occlusion is high. I can go to extra high. Let me demonstrate the high for you first, and then we're going to go ahead to go to extra high. There is a possibility that we can overload our VRAM, but let's go. Here we go. Yeah, the FPS decreased, as you can see. Yeah, we decreased the FPS from 7 to 5, sometimes even switching to 4. So it's taxing a lot in this particular game, ambient occlusion, the way they implemented this method. So 5 FPS decreased by 2 FPS, so way above 10% in terms of the performance decreased after enabling the ambient occlusion. And I can feel the stuttering now. Actually, I'm feeling it a lot, even if the FPS decreased by 2 FPS, but I can feel the stuttering a lot. It's heavy stuttering right now. Please keep that in mind. Okay, let me go ahead and go prone, pressing C. The keyboard response is not responding somehow. Come on, what's going on here? Here we go. Yeah, it's kind of slow. The response and everything is stuttering somehow. So ambient occlusion in this particular game is taxing a lot of GPU performance and the Turing GPU architecture. This will be the case on Maxwell GPU architecture and Pascal GPU architecture, and most likely an Ampere GPU architecture as well, because the Ampere GPU architecture is not even 2 times faster, even if Nvidia claimed that it's 2 times faster, but in real life it's not even 2 times faster than Turing GPU architecture. But either GPU architecture is amazing. The RTX 4000 series, especially RTX 4090, cannot wait to test this game in 16K video resolution on RTX 4090 video card. Hopefully it's going to be playable status, guys, not only benchable. I'm hoping for that. Look at this beauty. It's just beautiful, guys. The level of details. Every single pixel is right here. 132.7 megapixels rendered in real time. Excellent. So we saw everything what we need to see. Let me go ahead and skip that. Hopefully it's still recording the game with Nvidia Shadow Play in real time. Let me go ahead and close the game. There we go. I'm going to go ahead and return to the title menu. I'm going to click yes, and then I'm going to close the game. And I'm going to introduce to my PC configuration a little bit, to whole setup, and just go with you through some numbers for those people who is building the PCs. Just to underline it, to show you what kind of PC I was using today for those newcomers. Yeah, we utilize our video RAM completely, and pretty much we utilize our Titan RTX to the full possible capabilities and rendering abilities of that video card. It's taking some time to go to the menu because the game has loaded a lot of data in real time. Alright, so what I'm gonna do, I'm just going to go ahead and quit the game. Here we go. And remove that heavy stress. As again, I was only using 6 core, 6 threads, even if the CPU is 8 core, 16 logical threads, but we even didn't utilize 50% of our CPU cores, so we didn't bottlenecking throughout the CPU threads. Keep that in mind. So for those naysayers, let me real quick demonstrate first that my display settings is set to 16K video resolution, 100% resolution scale. This is very important. As you can see, everything is solid and not pixelated. If you're gonna use the zoom tool, 1000% of the Microsoft magnifier zoom tool on your 4K video resolution, everything will be so pixelated, but over here everything is so nice and beautiful. As you can see, as again, 100% scale is the recommended if you're trying to render exactly native 16K video resolution in all type of games. And let me show you the stats. Keep in mind that I did the benchmarks without the recording. So this is the raw benchmarks. 6 core, 6 threads scored 5.7 times, which is great score. As again, for PC gaming, we're looking at the single thread performance. Multi-thread performance is great when every single thread is utilized at 100%. This is exactly where you're going to take that advantage. For PC games in 2022, single thread performance, this is where we're looking at, because we didn't even utilize 6 core, 6 threads at 50%. So this is the comparison versus different CPUs. Let me show you. I was almost as fast as 5950X, which is much better AMD CPU and much faster CPU, but running stock, I was almost fast as that CPU. As you can see, dominating 3950X for sure. Let me go through some CPUs real quick. Go ahead and press the pause button. 10900K CPU, I'm dominating, as you can see, by some points for sure. I was way faster than hair faster in terms of the FPS in PC games. And this is the same CPU right here that I'm using. I'm dominating by almost 100 points in terms of the single thread performance. So in terms of the FPS, we are faster by at least 10%, as you can see, which makes sense. And as again, press the pause button to see if you're gonna find your CPU. I'm just going to go through some CPUs. Here we go. And if I'm going to add 2 more physical cores on hyper-threading technology, additional 8 logical cores, my level 1 cache, level 2 cache, level 3 cache in terms of read, write, and copy values, bandwidth will increase. But as again, latency delay will be the same. not changeable at all, and those values will be the same. So those values where you're going to look at when you're going to compare with your system latency delay in terms of the NS stands for the nanoseconds. The lower value is better. It's the latency delay between the hardware and software. This is probably the fastest DDR4 memory, guys. It's DDR4 3200 megahertz, but CL11. It's not CL16, CL14, CL11. The low value is better. It's a Micron chips, and it's DDR4 by Corsair 5000 megahertz, but it's not Samsung, it's Micron, so it's unstable on this motherboard. And let me show it to you. Unstable on this Z390 Asus Maximus 11 here motherboard, and so I kept it at 3200 megahertz CL11. So Micron chips love the low latency. Samsung chips in terms of the DDR4 loves the high frequency but high latency as well. Lower latency decreased nanoseconds in terms of the latency delay hardware and software, and maybe it's increased couple FPS, at least 1 FPS. There is a possibility. 1T command, as you can see, as again Corsair XMT 5000, which is 2500 megahertz times 2, 5000 megahertz CL18, but unstable on this motherboard. Micron chips. This is the Titan RTX when it was overclocked. Titan RTX was overclocked to the maximum stable in home safe environment. Overclocked to the software, highly recommend that. Boost up my performance by about 10% in terms of the FPS. So when I'm not recording and my Titan RTX running stock, this is how it was when the video card is overclocked, not recording, okay? 1250 megahertz on the video RAM overclock additional, and 1100 megahertz on the GPU overclock. We are running the bandwidth on in terms of the video RAM 20 gigabytes per second faster than RTX 3080 video card. However, when Titan RTX running stock, my bandwidth in terms of the video RAM is 100 gigabytes per second slower than RTX 3080 video RAM bandwidth, because video RAM on RTX 3080 video card is better than on Titan RTX, those GDR6 Samsung, and showing higher bandwidth. But right now I'm 20 gigabytes per second faster than bandwidth on the video RAM on RTX 3080 video card. Usually RTX 3080 video card is faster than Titan RTX video card when running both stock to stock, but just because Titan RTX is overclocked, I would say I'm equal than RTX 3080, or even a little bit faster, faster than RTX 3080. Okay, because RTX 3080 is Ampere GPU architecture, a newer GPU architecture. Okay, with more CUDA cores on board and such. So when I'm going to bring the Titan RTX to stock, you're going to see it exactly. In terms of the value, we decreased pixel fill rate by 10 gigapixels per second. I decreased the textual fill rate by 30 gigapixels per second, and I decreased the bandwidth by 120 gigabytes per second. So I achieve 120 gigabytes per second additional boost through my free software overclock, which is twice faster bandwidth, twice more bandwidth that I can push through my system RAM, because system RAM maximum capable to push 50 gigabytes per second or 50,000 megabytes per second. If I'm going to clock my DDR4 to 3300 megahertz, is going to be 50 gigabytes per second or 50,000 megabytes per second right value. But as again, it's not going to be fully stable after 4 or 5 hours. It's freezing. But this 3200 CL11 completely stable and not freezing. I think it's a little bit overheating when I'm running 3300 megahertz CL11, because I'm using very high voltage on DDR4. Okay, it's like 1.75 volts, which very high on DDR4. But for the Micron chips, it's still great for this particular DDR4, because this particular DDR4 by Corsair was using from the stock 1.6 volts. Way higher than 1.5 volts or 1.25 volts on a regular DDR4. Keep that in mind. Alright, that's pretty much it, guys. As again, I showed you everything what you need to see. Today was November 5th, 2022, but those type of technologies was available to us back in 2018. It is early morning. Hopefully you're having a great morning, good day, or good evening. Don't forget to smash that like button in terms of the support. A lot of time, money, energy was supported. Positive comments, subscribe, share it with your friends. On the background, this is my system. I'm using the Corsair H150i Pro 360mm radiator with three 120mm fans. Any AO with 360mm radiator will be Gucci here while running i9-9900K at 5.3 gigahertz, but with only 6 cores, 6 threads, because it's going to overheat everything above 5 gigahertz, even on a Corsair H150i Pro with the liquid metal thermal compound paste. Everything above 5 gigahertz with the 8 physical cores, 16 logical threads will be overheating on the Intel Core i9-9900K, even with 360mm radiator, guys. Keep that in mind. All right. So pretty much everything was discussed with you. As again, right now I'm putting some great videos for you to check out. 8K resolution, 10K resolution, 12K resolution on the same system, including the two Titan RTXs in 16K resolution that you don't want to miss. Check out the video description for those videos, or right now I'm putting those videos for you to check out, or check out the video comments as well. I'm going to add more videos throughout within the newer hardware as well. And as again, have a great day. Support me, guys. Till the next time. UG King, aka I play 4K, aka I play 8K, aka I play 16K. And during this video, I demonstrated 16K video resolution, 16K gameplay, 16K gaming, 16K benchmark, 16K UHD in the Metal Gear Solid 5, the Phantom Pain. Alright, guys, so I decided to go and give you away some free game on Steam. I cannot give you away Metal Gear Solid 5, the Phantom Pain PC game, just because this is the world's first 16K UHD benchmark in Metal Gear Solid 5, the Phantom Pain PC game. I decided to give away Metal Gear Solid 5 Ground Zero PC game on Steam, which is the previous episode. Still great game, almost as good looking game as Metal Gear Phantom Pain. This is the code. You gotta activate it in Steam on the existed account, or just create a new account. It doesn't matter. It's gonna activate the full game, the full PC game. It's prepaid, legal, prepaid by me. This is the UHD King gift. Please let me know who you are. This is the first activator. If you didn't win this time, subscribe and keep watching my videos as the first watcher, and you're gonna win another time. All right. Thank you so much for watching. Right now, have a great day, and till the next time, guys. All right. As again, check out those videos that you can see right now on the screen.